Alright guys, today we're going to talk about tapers and taper formulas. Right. A taper is a consistent change in diameter in a given length. So pretty much you have a bigger end, it tapers down to a smaller end. If you look up here on our taper formulas, I've given you all the letters. You got your big D, which is your large diameter. You got your small d, which is your small diameter. You got your L, which is your length of your taper. One thing I didn't put up there is there's an LW. Some people put a TL for total length. That would be if your taper ended and you had the shaft keep on going, that would be your total length, or your LW, which is also total length. People label it differently. You have your A, which is your angle of the taper. You can find this angle of the taper with just having your two diameters and your length. You got TPI, which is taper per inch, not to be confused with threads per inch. In tapers you have a TPI, and threads you have a TPI. Then you have TPF, which is your taper per foot. Alright. You have different types of tapers. You have a Morris taper, which is approximately 5/8 of taper, 0.625 of taper per foot. That's commonly found on your drills, on your reamers, on your tailstocks, in your drill chuck spindles. You have a Brown and Sharp taper, which is approximately 1/2 inch per foot, which is found on Brown and Sharp machines. Then you have a Jarno taper, which is about 600 thousandths in a 12 inch in a foot. Alright, that's found on lathe spindles and drill spindles. Then you have taper pins. Taper pins are also called aircraft pins. They have a slight taper, which is 250 thousandths in a foot. They're used for alignment and stuff like that. Taper pins, once you put them in, you have to beat like crazy to get them out. They're not like your Jacob's chuck or your center that goes in the tailstock. When they come in, you just pop that tailstock loose and they come out. That taper pin, you're going to have to drive it out. It's going to take some force. Alright, in your packet here, if you flip over a page, we have formulas that give you the offset for your tailstock if you're going to cut a taper on the lathe. Alright, it goes through and it pretty much gives you the same thing I have right here. It shows you how to convert it from taper per foot to taper per inch, to taper per inch, to taper per foot, and then it gives you the formula. If you go on down a little bit, it gives you a formula for if you have the taper per foot and the overall length given, and then it gives you if you have the taper per inch and the overall length given, and then if the TPI, taper per inch, or the taper per foot is unknown. These are all formulas for offsetting the tailstock. Alright, if you go on down a little further, it has examples. Example 1. Alright, it says you have a 625 thousandths taper per foot, which is 5/8. What kind of taper would that be? A Morris taper, that's right. Okay, so if you have 625 thousandths taper per foot, you do your taper per foot times the overall length divided by 24. Okay? So it's saying, this example is giving you an overall length of 6 inches on your taper. So you do 0.625 times 6, which gives you 0.375. You divide that by 24, and that gives you 0.56 or 0.156. Alright, that's how far you offset that tailstock. Okay? The reason you divide it by 24 is it's 2 times 12, which is 12 is your foot. You want to do that 2 times because you want half of the overall change. So say you have, on your big end, you have 3 inch 375, and you have a foot worth of taper. On your small end, it's 625 thousandths per foot. It would be at 2 3/4, 2.75, something like that. All right. Well, that changes 625 thousandths. Well, if you're going to offset your tailstock, you're not going to offset it the whole 625 thousandths. You're going to do half of that because you're cutting on one side of the part. All right. Another example is if you have just a taper per inch. It says you take the taper per inch times the overall length, and then you divide it by 2. All right. On your taper per foot, you divide it by 24, which is 2 times a foot. On your taper per inch, you divide it by 2 because you want that number in half. You're going to come with the same answer no matter which formula you use. All right. So it says you have 52 thousandths taper per inch. Multiply that by 6. Divide it by 2. You're going to come out with 312 thousandths divided by 2, which gives you the same answer of 156 thousandths for that formula. All right, and then there's one last formula that says if no taper is given. All right, that means you're going to take your big diameter, subtract it from your small diameter, or subtract your small diameter from your big diameter. All right. So here it says you have 1 inch minus 844 thousandths. Then you're going to multiply it by your length again, which is 6 inches. All right. And then you're going to multiply 2 times the total length, or the length of the taper. That does not sound... Anyways, what they're saying is you're going to take your big diameter and subtract your small diameter from it. So they gave you an inch for the big diameter, and they gave you 844 thousandths on your small diameter. That's going to give you 156 thousandths. You're going to multiply that by 6. You're going to come out to 936 thousandths. All right? And then you're going to divide it by 6 because it's 3 times 2 on the formula. That's going to give you 156 thousandths as well. So either way you go with it, whether they give you the taper per foot, or whether they give you the taper per inch, or they don't give you the taper, as long as you have these numbers here, you don't even have to have the A. As long as you got the big diameter, the small diameter, and the length, you can still come up with how much taper per inch or how much taper per foot. All right. And if you flip over on the back, on the next page, that just shows you how much each example we just covered. So you have your 6 inch long taper with your 625 thousandths per foot, and then you have your taper per inch formula, and then you have the last one where it doesn't give you a taper per foot or a taper per inch. All right. On your desk, you also have this sheet here. It's just got a bunch of problems on it. It's got the big D, the little d, and the L on it. All right. We're going to work through it, and we're going to figure out the taper per inch and the taper per foot for each problem. If you need more than just this one packet, there's another paper on your desk. It's a little more complex. It gives you multiple ways of going about getting the same answers you will off of this packet. All right. It gives you, for your taper per inch, it gives you how to find it if you have a taper per foot, how to find it if you don't have any of that, if you just have your big diameter and small diameter and length, and then it has a way to do it if you just have the angle. Okay? And it goes on and tells you how to do it for each. If you just have a taper per foot, or finding the big D, finding the little diameter, anything like that. All right. On this worksheet, for number 1, I want you to find the taper per inch and the taper per foot. So what would you do for number 1 to find the taper per inch? Justin.
First, you'll subtract the small diameter from the larger diameter,
Alright,
and then you'll multiply that by your overall given length,
alright.
and then you'll divide that by I guess that'd be the total length of the taper itself, times 2. And then you'll
Okay.
divide those together.
You're on the right track. So we're gonna take our big B, which is equal to 1.625. Then we're gonna subtract the little d, which is 1.305. Alright? And you come out with 320,000. Alright?
I got 320.
305, 220, or 1.625 minus 1.305?
Yeah, there you go.
Alright.
I didn't have it.
Now, it gives you the length. L of 3 inches, 250 thousandths. Okay? This number right here, you're going to divide by 325 thousandths. Alright? Somebody throw that in a calculator, tell me what you get. 320 thousandths, 0.32 divided by 3.25.
0.098.
0.098. Okay? That is going to be your taper per inch, guys. When it gives you a total length, you divide that number that you just got from subtracting the two numbers. You're going to divide it by the total, by the length of the taper. That's going to be your taper per inch. And then if you want to find your taper per foot, that 98 thousandths, that 0.098, you're just going to multiply it by 12, which is going to give you 1.181. Y'all understand how we just come up with that? Alright. Y'all try the next one real quick by yourself. I'm not going to erase it.
I never wanted this little experiment to be like that. We're not as my family. I was telling Karen before that it was the objections were doing no protection. And the Lord said, what's the policy? Well, it's in the central of the bureaucracy. It's in the bureaucracy, not out here. You must have weapon system in the service to still have an operational test cycle. People might get killed. You know, I can't take my money out of here. 7,000 people in prison. Nobody runs the damn thing. Programs just panic.
Maybe that's what.
Just three. As soon as y'all get the taper per inch or the taper per foot, let me know. Alright, you got it? Alright. Tell me what you got and I'll check it.
Taper per inch is 0.119. Taper per foot is 1.428.
0.119?
Yes.
That's right. So this is gonna be 0.119. Then you're gonna multiply that number by 12. You got
1.428.
0.28.
Yeah.
Alright, 1.428, 1.30. It depends on how many decimal places you want that. Alright. So that's going to be your taper per inch and your taper per foot for the second. I believe y'all got it. The next one's easy. Go ahead and just give me the taper per inch for the next one.
Right now, remember.
That's right.
Yeah. 0.1.
0.106. Alright. And since your length is only 1 inch long, that's already your taper per inch. So all you'd have to do is multiply that number by 12 to get your taper per foot. Alright. I believe y'all got it. I believe y'all understand it. We're going to walk out to the shop and go ahead and continue this a little further, and I'm going to demonstrate it on the lathe. Thank y'all for your participation, guys.